Lesson 4.1. Our outcome is going to be to write simple and compound inequalities, solve and graph inequalities with one variable. So our first thing that we need to look at is we need to define inequality. An inequality is a statement that is formed using an inequality symbol. And these should be familiar to you. Less than, greater than, less than or equal to, greater than or equal to. And you can always hold up your hand and make an L, and that's the one that's less than. Okay? So you might want to take a moment and jot those down for yourself, but those should be review. Words to look for, indicators are going to be under, indicates less than. Over indicates more than. It needs to be over 5, so that's going to be greater than. No more than indicates less than or equal to. So that than part includes the equal to. At least, it has to be at least 5. It can be 5, but it has to be at least that. It could be more than that. So it indicates that it's greater than or equal to. An example of this, an airplane. To avoid turbulence, a plane must fly no less than 33,000 feet. So it has to be no less than. So we have our less than symbol, okay? And it can be no less than. So x has to be bigger than 33,000 feet. So we have our 33,000, and there's x. X has to be greater than 33,000 feet. Okay, so a plane can fly no less than this, meaning it has to fly at least 34,000 feet. Okay, so you just have to read it a couple of times to figure out where the symbol goes. Mark needs to earn more than $55 to buy a new skateboard. So we know 55 is going to be in there, and we know X is going to be in there. He needs to earn more than. So which number needs to be bigger, the 55 or the X? Good, the X. It has to be bigger. So give yourself an example. 60, is that more than 55? Yes. So we can plug that in there. Compound inequalities. Those are formed when you have two inequalities that are connected by the word and or. It simply means you're going to have two inequality symbols in the same statement. So you'll have like an X in the center, and you could have 2 over here and maybe 7 over here. So X has to be greater than 2, and X has to be greater than 7. So an example of that would be 8. Is 8 bigger than 2? Yes. Is 8 greater than 7? Yes. So that would make that statement true. So here's an example. All numbers greater than 1 and less than or equal to 5. So all numbers, that's going to be our X, because we don't know what the all numbers are, needs to be greater than 1. So X has to be greater than 1. So we want the alligator eating the X. It's bigger than 1. And less than or equal to 5. So we know 5 is the other extreme on our compound inequality. Less than or equal to 5. So X is less than 5, and X is greater than 1. So an example that would make this true. A number bigger than 1 would be 3. Let's see if 3 makes this true. Is 3 less than or equal to 5? Yes, that would work. Graphing our inequalities. We have two symbols. We used a closed circle and an open circle. A closed circle will be for something that has an equal sign. A greater than or equal to, a less than or equal to, or equal to. It means we want to hold on to that solution. If we have an open circle, that means we're not including this number as a solution. It will not make it true. So an example of that is X is less than 3. We know our circle has to be on 3. Do we want to make 3 a solution? Will 3 make this true? Is 3 less than 3? No, it's not, so we don't want to include it. But numbers that do make this true are 0, 1, 2. Okay? So we want to shade the number line in the direction of those numbers because they all make that true. You could test negative 10. Is negative 10 less than 3? Yes, that's true. Now, you might want to pause here and do this one on your own before I give you the answer. X is greater than or equal to 4. We know we have our circle on 4. Is it open or closed? Closed, because we want to hold on to it. That equal sign means that it can be a solution. Okay? Greater than or equal to 4. Those are numbers like 5, 6, 7. So we want to shade in that direction on the number line. Okay? And does 4 make that true? Is 4 greater than or equal to 4? Yes, that's a true statement. Now we have a compound inequality that we're going to graph. So we want to break this into two sections. I want to look at just this piece first. X is greater than negative 2. So I have my open circle on negative 2, and I need things that are greater than negative 2. And I'm going to shade in this direction. Okay? Now, X has to be greater than or equal to 4. So here's my 4. Greater than or equal to. I'm going to give it a closed circle, and I need to shade this direction. So in order to make this true, I can pick any of these numbers out here. If I pick 7, I plug in 7. Negative 2 greater than 7 greater than or equal to 4.
Please excuse this interruption for an after-school announcement.
7 is greater than negative 2, and 7 is greater than or equal to 4.
Chorus band and orchestra members are reminded that your fundraiser is over. Order forms and money were due.
Okay, lesson 4.1 continued. The announcements are over. The final section is solving the inequality. Okay, so this is just like a two-step equation. The only thing that's different is we don't have an equal sign. We have an inequality symbol. You do it the same way. Draw your line down the center, and we need to isolate the variable. So the constant goes home first. The inverse of positive 3 is negative 3. These cancel. I'm left with 2x is less than or equal to 10. The inverse of multiplication is division. So we're going to divide by 2. X should be less than or equal to 5. And before you graph it, you want to test it. Does that work? A number that would make that true would be 4. So let's plug 4 in up here. 2 times 4 is 8, and 8 plus 3 gives me 11. Is 11 less than or equal to 13? Yes, that's true. So we know that we did this correct, and we justified our answer. Yours would be much neater on your notes, folks. Much neater. So in order to graph this, the only real numbers you need are 0 and this number right here, and 5. Are we going to do an open or closed circle? Closed. Good, because 5 could be a solution. That would make that statement true. And we need to be less than, so we need to shade in the direction of 4. So we've shaded in to the left because all those numbers would make that true. Now, these two look to be very similar, but they are different. One thing makes them different, and that's this negative sign right here. And I want to show you what happens when you multiply or divide by a negative. Do the same thing. Get rid of the constant. Negative 3 on both sides. That cancels. Negative 2x less than or equal to 10. We're going to divide by negative 2. Divide by negative 2. Those cancel. X should be less than or equal to negative 5. Well, let's test that and see. A number less than negative 5 would be negative 7. So if I did negative 2 times negative 7, what does that give me? Positive 14 plus 3. 14 plus 3 is 17. Is 17 less than or equal to 13? No. It is not. That is not a true statement. What we need to walk away with this is, if you multiply or divide by a negative, you have to flip the sign. So this is not x is less than or greater than -5, less than or equal to -5. It needs to be x is greater than or equal to -5. This is the biggie, folks. If you multiply or divide by a negative number, which we did right here in this step, you have to switch the sign. So again, we have 0 and we have -5. I have a greater than or equal to sign, so that's going to be a closed circle. And we shade in this direction. An easy one to plug in is 0. -2 times 0 is 0. 0 plus 3 is 3. Is 3 less than or equal to 13? Yes. So that makes it true. Okay? Please be very careful. You might want to pause it right now and try another example on your own. What I want to show you is multiplying or dividing by a negative, you must always flip the sign. And I'll leave it on this for you.